cubed minus 2x to the 4. If you look, all of these are more simple, right? So multiplying by something probably is going to get you there. So let's divide them out. The top, I could take out, all of them I could take out a 2 and an x squared. That's the 2x squared, and summation for minus 6 over 4x cubed minus 2x1. Remember we said equivalent has to come out of everything, right? Simplifying it can come out of the top or the bottom, but when it's equivalent, it means it has to come out of everything in order for it to be equivalent, right? So out of all of them, I can take out a 2 and an x squared. So it's small. So 12x squared divided by 2x squared is 6, minus 6x cubed divided by 2x squared, 6 divided by 2 is 3, x cubed divided by x squared is just that. Over 4x cubed divided by 2x squared. 4 divided by 2 is 2. X cubed divided by x squared is x. Minus 2 divided by 2 is 1. 4 divided by x squared is x squared. What else can I do? Okay, so go to the top. 3. And then I'll be left with 2 minus x. Okay, so down the bottom. Next. 2 minus x. It's the bonus. Why would I put this one on here? This is part equivalent and part simplifying, which is what we're going to do. Okay, this is the bonus. This is the test to get 2. So get this, yeah, you didn't. Yeah. 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 Okay. So you have to be able to, today what we're going to be doing too is, hey, is there anything common that I can get them that I can cancel off, right? Or we're simplifying. This is leading into today. The non-permissible value, 2x plus 1, 3x minus 9. So I could take a 3 out, and then I'd be left with x minus 3. If you didn't take the 3 out, that's not a big deal. You'll still get the same. So 3 can equal 0, and then I have x minus 3 can equal 0, x can equal 3, and I have it over. You fill in the numeric response box, you fill in left to right, and only the amount of boxes you need. So you're not going to go 3.00, okay? All the boxes do not need to be filled in, and you have to fill in from left to right. If you fill in from right to left, they're not going to give it to you. Left to right, just like you read. You read from left to right, you fill in from left to right, okay? So for today, obviously, you're not going to drop for that. But on the diploma, they won't give it. It's a machine. It has no, like, love for you. It has no heart. It doesn't know you. It's a machine. A little piece of paper shoots through the machine. The machine tells you what your mark is, right? There's no one going, oh, I'm pretty sure they just meant to put this in the other box. There's machine, right? Explain why the non-permissible value for this expression is x plus 2 is -2. How can we explain that? What comes the denominator is 0. So we could say the denominator, or the bottom, denominator better, and now equal 0. Therefore, x plus 2, which is the denominator, can't equal 0. You solve it. X can't equal 0. That is the proper way to explain. So your text is out of 2. You can put a mark at the top. Out of 2, each question is worth 1. I know the first one is the bonus. Okay. If you have any bonus, kind of goes that way. That helps. So, what we've done so far with rationals is we've done non-permissible values, also for restriction. We've we've done equivalent rationals where we multiply the top and bottom by the same thing, then we divide the top and bottom by the same thing to be equivalent, right? Now we're doing simplifying. Simplifying means make more simple. The only way you can make something more simple is by dividing the same terms out, right? Trying to make it more simple. Multiplying gets you equivalent, and simplifying gets you equivalent. Multiplying and dividing gets you equivalent, but multiplying doesn't get you simplifying. You can't multiply something and make it more simple. You're making it more complex if you multiply it. Okay? So, simplifying. The very first thing you want to do when you want to simplify is you want to look at the numerators and you want to look at the denominators and say, can I take out a GCF for difference squares? Okay? That's what we're going to do every single time. So we're going to factor the numerator, the top, and the denominator bottom if possible. What does that mean? GCF difference squares. That's the first thing you want to do, GCF difference squares. Then we say NDVs, because the last step is to simplify, cancel off stuff that's the same. You need to say NDVs before you cancel. If you go to cancel with your pencil and you haven't said NDVs, slap your hand and say no. Yes, like that. And you state NDVs first. You cannot state them before you cancel. So what kind of answer do you think will have a little comma as a distractor? NDVs without, NDVs after you cancel. Because if you state the NDVs after you cancel, you're wrong. The reason why you have to state them before you cancel, you have to say NDVs before you cancel always, is because if you don't say NDVs, right, NDVs tell you what the variables can't be because the denominator would be 0 then if it was that value, right? And we can't have that. If you say them after you cancel, you're missing one of those values that it could be that would make the denominator 0 at the very beginning, right? You always have to state non-permissible values before you cancel. Always. Anytime or not. Okay? So, express the following rational expressions in simplified form, stating the non-permissible values. You'll be stating non-permissible values like crazy. So by the end, it's just be part of your routine. So, what I always say is GCF difference of squares first. So I have 12x squared. Can I take out GCF for difference of squares? It's a monomial. Monomial means one term. There's no two terms. If there's not more than one term, there's no difference of squares in GCF because there's one term. Can't take it out of more than one, right? So what I do tell you though, because we used to do this in grade 10 in the old curriculum. We do it in grade 11 in the new curriculum for 20-1. And it comes to 12. When I first taught this, I would get the quiz back and people would just fall on the simplifying because they wouldn't remember where they can cancel and when they can't cancel. So what I have found works is that if anything is not attached by a plus or minus sign, it gets put in its own bracket. Okay, so there. I have 12x squared. 12 and x squared are multiplied, correct? They're multiplied together. There's no plus or minus sign. But they're multiplied together. The way you can represent it being multiplied together is in their own bracket. Like I can write it like this: 12 times x squared. Remember, when two brackets are touching, that means multiplied, right? So whenever anything is multiplied, please put it in its own brackets. It will make simplifying and all the rest of that multiplying and dividing so much easier to do. On the bottom, I have a 2 and an x. So I'm going to go 2 and an x in its own bracket. Anything that's attached with a plus or minus sign goes in its brackets too, right? Like they're attached, so they have to go in a bracket. These are done. So now I'm like, okay, I want to cancel. And I say, no, you can't cancel until you state your non-permissible value. So I have 2 can't equal 0. And 2 can't equal 0. Is that possible? 2 just can't equal 0. So I don't have to state non-permissible values for that one, right? And then this one I have x can't equal 0. And then that. Last thing I want to do then is cancel off anything that's the same on the top and the bottom, and the numerator and the denominator. That's math. Okay? So I have a 12 and a 2. Is there anything I can take out of both of those? 2. Now, 2 or 12 divided by 2 is 6. 2 divided by 2 is a 1. Why do I have to write the 2 when I pull that 2 out? I could write the 2's, but they would just cancel, wouldn't they? If I took a 2 out, I could go like this, 2 times 6. And 2 times 1, I could technically do this, right? These would cancel, so they just go away. So when you can take something out of the top and the bottom, you don't have to write that 2. Take it up and cancel it off. Okay? Now on the top I have an x squared, and on the bottom I have an x. So on the top I technically have an x times an x, and on the bottom I have 1x. Correct? So I can cross off 1x for 1x. And then I'm left with a 6 and an x on the top. You can put it on the bracket if you want, or just write it on the side. And nothing on the bottom. Do I have to write the 1? When it's in the denominator? No. If it's in the numerator? Yes. So B is nice. A plus 1 times A minus 6 over A minus 7 times A plus 1. First thing I ask myself, can I take out a GCF? Or this is the squares? No, they're factored already. Now this is where people are going to take A plus 1 and A plus 1 and get really excited and cross them off. So before you cross them off, what do you have to do? State NPV. So I know these ones, like you're so happy that something's going to cancel and you can see the right answer, and you cancel them off for NPVs. Do not be that person. Stop yourself and really know. Okay? So I'm going to get non-cancelled items in this one and this one. A minus 7 can equal 0, and A plus 1 can equal 0. This one I have 7. So A can equal 7 minus 1. A can equal negative 1. So I get A can equal negative 1 7. Now when I have my NPVs actually stated, then I can cancel. Anything that matches exactly the same on the top as on the bottom, right? So I have an A plus 1 and an A plus 1. Now this is where people go crazy. Like they just really want a super nice answer like 2 or something. So they start canceling off stuff that you can't even cancel. So they'll go, okay, this is an A, this is an A. You cross them off. No. If it's in a bracket, so A minus 6 is in a bracket, the only way that is it minus 6 plus? A minus 6. So if A minus 6 is in a bracket on the top, the only way it is going anywhere is if A minus 6 is in a bracket on the bottom. Is it? No. You only cancel. When they have a plus or minus sign in the middle, they have to match exactly the same. Okay? So A minus 6 is not on the bottom, it's staying forever. A minus 7 is not on the top, it's staying forever. You can't make it any more simplistic. You can't cross off those A's. I cannot tell you how many times the first quiz I hand out people are crossing off those A's. You're that person who's like, I would totally cross off those A's. You will know there and say, don't do that. They can't cancel unless they match exactly. And that's probably happened to you and you're dying at yourself. So I bet you would have crossed those A's off. Okay? So don't do that. What's left over? A minus 6 on the top, A minus 7 on the bottom, and we're done. Okay? C. I have 8y plus 2 on the top, so the binomial, 2 terms. 8y plus 2 on the top, and then 8y in the denominator at the bottom. Okay? First thing I ask myself is GCF difference of squares. So in the numerator, the top, 8y plus 2. Can I take anything out? 2. Can I cancel it off? Doesn't exist? No. The only way it doesn't exist is to take out the top and the bottom, right? So not. So I get a 2, and then 8y divided 2 is 4y. And then this is where that error happens. What's 2 divided by 2? Plus 1. Okay? That's another common thing that's going to happen on the quiz. We're going to go 2 times 4y. Not 2 times 4y, it's 2 times 4y plus 1. And 2 divided by 2 is 1. Okay? That happens a lot. And then the 8 and the y, are they attached by plus or minus sign? No, so I write them in their own brackets. This 2 can be in some brackets. So, next thing I do, I state NPVs, right? They can't cancel until I state it. So, H can't be 0, true, but it's an H, and then Y can't equal 0. So that's my only NPV. So I've stated non-physical values. Okay. I deal with binomials first so that you can see that they're not going anywhere. So 4y plus 1. Is there a 4y plus 1 on the bottom of the bracket? No. This is staying, guys. It's not going anywhere. No matter how much you want it to go away, you want to cross this y off with this y, you cannot do that. Okay? This is one term. When it's attached by plus or minus sign, that is one term. So unless that exact replica is on the bottom, you're doing nothing with it. It's staying for life. Okay? Now I have a y on the bottom. Is there a y or a y squared would work, or a y cubed by itself would work, or a y4 would work, right? Because those are by themselves. Is there one of those on the top in the numerator? No. That baby's staying for life too. That's not going anywhere as well. Now I have a 2 on the top and an 8 on the bottom. Is there anything common to those? 2, right? I can take a 2 out of both. So 2 divided by 2 is 1. And I can only do this because they're like coefficients. They can number by themselves in the brackets, right? If we had a variable with it or something, I would have plus sign, and I couldn't touch it. And then 8 divided by 2 is 4. So on the top, I'm left with 4y plus 1, and it's not going anywhere. Because there is no 4y plus 1 on the bottom in the denominator. And this is going to be 4 and y. Could I go 4 and y in its own bracket? Absolutely. In the answer. Okay. We're going to do E and F. We're going to try E and F. Will be D last subtraction. Let's try E and F. See how you do it. All right. E. We have 12p squared minus 8p. What can I take out of both of those two terms? How that finally bigger. 4p. And we got a 4p. 12p squared divided by 4p is 3p. Minus 8p divided by 4p is 2. Then this 4p can go in their own brackets, right? Go in their own brackets to attack the multiplication. So equal sign outside. So an equal sign to this equals that. That's like. Then we have 6p cubed minus 4p squared. What do we take out? 2p what? 2 squared. Because those are multiplied and put them in their own bracket. We take out a 2p squared out of 6p cubed. We're left with 3p. Minus 4p squared divided by 2p squared is 2. And at this point, most people are like jumping up and down because they're seeing that there's something that's common that's getting canceled. They're like, I don't see anything correct. Or big right. All right. So what happens is you super excited and you start canceling. No, you have to stop yourself. Remember, NPVs first. So does this 2 get you an NPV? No. P squared, P cubed, P4, P5, P6, P7, all are just P can't equal 0. Now, why is that? Because if I have P squared, that's just P times P, is it not? So I can say P can't equal 0 and P can't equal 0. Well, I only have to write it once. So if it's P squared, P cubed, P4, P5 by itself, then your NPV is always P can't equal 0. So I know my NPV for that one. P can't equal 0. And then this one I have to solve. So I have 3p minus 2 f equals 0. 3p can't equal 2. Divide by the 3. P can't equal 2. So my NPVs are P can't equal 0, comma 2/3. Now, I have a 3p minus 2 at the top. I have a 3p minus 2 at the bottom, so they can cancel. I have a p and a p squared. Can they cancel anything off? P squared is just p times p, right? So I can take off this 1p and one of these. I'm left with p1, or just p. And I can take a 2 out of 4 or 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And I'm left with 2 on the top in the numerator. And p on the bottom in the denominator. And I don't know why I did that one. F. F, in the numerator, I can take a 3 out, so the GCF. And I'm left with t squared minus 25 over t plus 3, t minus 5. And a lot of people will sit here long enough and freak out and be like, I don't know what to do next because they forget about difference of squares, which happens a lot, trust me. Or they're like, sweet, 3, 3, this t squared cancels off this t, this t. I've seen the craziest canceling you've ever seen, and they'll end up with like negative 25 divided by negative 5. Okay, that's 5, and I'll get 5 as the answer. You look at me straight, but that is half of you. So please don't, maybe even more. So don't feel like because you think, if you think you're stuck and you're like, there's got to be something else, think it's probably difference of squares. Don't think I can cancel crazy things off, okay? 99% of the time when people are stuck on the test, they call me over and they're like, Lepp, this question doesn't work. I'm like, you're forgetting something. They're like, no, I'm not. You're forgetting something. No, I'm not. And then I walk away and you're mad at me. It's because you're forgetting difference of squares and I can't tell you that, okay? That is 99% of the problems on the test, is that you forget difference of squares and squares, okay? If I walk away and you're mad at me, I promise you it's probably difference of squares, okay? So, t squared, square root t squared is t. Square root 25 is 5. So you get 3 t plus 5, t minus 5, that's raising its own bracket. And on the bottom, I have t plus 3 and t minus 5. When I do my NPV, it's going to be t tends to equal negative 3 or 5. Okay? Now, once I save my NPVs, I can cancel them off. The t minus 5s go away. Now, people want to cross off these t's. Can you do that? People want to cross off these 3's. Can you do that? T plus 5, anything that's in its own bracket is only going anywhere if there's another bracket in the bottom of the cup that matches it. If there's not a twin to that bracket, you're not doing anything with it when it's got plus or minus sign. So it's a t plus 5. There's no t plus 5 on the bottom. That may be staying. There's a t plus 3. There's no t plus 3 on the top. It's staying, right? And the only thing you have left is the 3. So that's as good as it gets. Don't try and make it better. 3 t plus 5 over t plus 3. So what I want you guys to work on, we're going to have homework on Monday, but not today. We'll have to go home on a long weekend without homework. So, I want you to work on the examples. So I want you to try the your term that's below, and I want you to try the example 2 and the your turn and the example 3. I want you to try them. We're going to go through them on Monday, but it would be nice if you tried them first because then you can catch where your errors are. If I just go through them, everyone's like, oh, that's not bad, and then they get to the homework and it's like, I don't know what to do. I don't want you to do that with people. So just start working through them, and as far as you get is as far as you get, and only homework for 1 week and it being nice. Okay? So just work.